what is this number?
Oh.
Kinetic energy.
So what are the nice units for kinetic energy?
Joules.
Joules. So 0.4 joules.
Oh, wait, so what's the answer? It was 0.426?
I think it comes down to if you use 0.03, you get that. If you do the 0.03 repeating a whole bunch of threes, you get this.
Oh.
So I'll just make it 0.4 joules. Now, when we dealt with joules before, joules actually is defined as a kilogram meter squared per second squared. But we got this extra radian thing in here. We got radian squared, but somehow I said, let's just make it joules. What happened to the radians?
You were evil and threw it away.
Not evil, it's just misunderstood. Let's think back to how a radian was defined. Got my circle here, I have some radius r, I wrap that around. So that arc length is r. If I did two of them, that's 2r, and that angle would be 2 radians. There's a relationship between this arc length and the radius and the angle. The arc length is equal to the radius times the angle if the angle is in radians. So if we do an example of, let's say I have a circle of radius equal to 2 meters, and I have an arc length of S, this is an arc length. And I have an arc length of 3 meters. So 1.5 radiuses. I have 3 meters is equal to 2 meters times my angle. I divide by 2 meters, divide by 2 meters, and I'm up to 1.5 radians. Now here's a situation where radians appeared out of nowhere. Because meters would cancel out, so there really shouldn't be anything there, right? It should just be 1.5. Here's the beauty of radians. It's a unitless unit. You can put radians in or take radians out whenever you feel like it. A couple years ago, I had a student who always stuck rad after every problem. When he put the units in there, he always stuck a radian. Not technically wrong. If radians are sort of unitless, in other words, I can define an angle based on radians, but it doesn't, if I can magically put it in or take it out whenever I feel like it, why on earth did they bother coming up with a name for it? It's communication. If I say that the angle is 5, I think a large number of people would think I just didn't say degrees. But technically, if I say it's 5, that's 5 radians. So you use radians just to make it clear that you didn't forget the units. You're not dealing with degrees. So radians go away when it's convenient, and you put it in when it's convenient. So it's convenient to ignore that because that's a joule. Questions to hear?
So you're supposed to be dividing the arc length times the radius, by the radius.
If you do the arc length divided by the radius of the circle, that will tell you how many, the angle in radius. I felt like there was a follow-up.
No.
Okay. Other questions at the moment? I'm going to grab a couple more props because there's always more. Sorry, I got spoiled by a previous classroom where everything was always there, so. Not used to this. So,
Do
but
you
yeah.
have a lab today?
Pardon?
Do you have a lab today?
I, probably not, I think. But, we'll see when we get there. I'll be back and I'll just put that on.
At that point, I was just like, whatever. I mean, I was so over it. What is it feels like
Yeah, so he's just taking.
But what I don't understand is how did he, how are
So you can go up like if you hit enter, it'll just bring it back down. Yeah, I know that.
No.
So that's how I got that answer.
Oh, what?
So you just hit enter and it'll
Oh, that's cool.
that's how it's done. But I just put it in.
There's no way I was gonna get ready. Yeah, it seems like simple. I was so like that. When it actually takes time to like, I don't know.
So I wouldn't even worry about like this part with like the eyes and shit because it's just this is shorter than this, so we don't even really.
So that's why I like, every single time I do this, I'm literally just like,
I don't think they can use pictures.
there's no
That's so for this, it's just solve it for I here. That's what we got. And then just take this and put it in this for connect. Yeah, so this formula was in our textbook. That's where it is. So we're just taking this number and plugging it into with this. Okay.
it's another
Yeah, like two weeks ago. Then we took our test.
Apparently I tried to do it so bad. Yeah, I need. All right, so. I have two cylinders. They are roughly the same diameter. This one is going to have greater mass than this one will. It's wider, so hopefully you can see. If I roll them at the same time down here, which would get to the bottom first. So we're going to see about physics by democracy. All right, so we have the fatter one, the skinnier one, a tie, or they burst into flames and never make it. I hope it's not the last one. All right, so have an opinion, even if you can't back it up. I'm not going to ask you why you voted the particular way right now, it's going to. We're going to do a couple trials before I ask anyone why they think that way. So just gut feeling. Please have an opinion and vote. The fatter one will make it down first. The skinny one will make it down first. 6, 7, 8, 9, 10. A tie.
Oh, sorry.
Neither. So roughly split. Now to release them, there are two things I do need to take into account. One of which is there a bias in this? So I'm going to do it twice. Once in this position, the other one in that position, just to see if that makes a difference. I need to release them at the same time. So I'll just use this. And go. Roughly the same, roughly. The width did not have a significant difference there. Well, let's do it the other way. Just it helps that they actually both move. Apparently that's got an issue. Ooh, that's not actually a circle. Let's go with the first one. I'm going to change it to this one right here. It's basically the one that I was using was this, except stripped down a little bit more. Anyone want to change their vote?
Did you say they had the same difference?
The same what?
Difference?
Roughly. Yeah. You
I'm gonna say tie now.
want to try? Oh, well, I guess we've already done it once. Depends on how much faith you have in that first one.
I thought one was skinny, like the circumference was smaller on that, it's skinnier,
Oh.
so that's why I said that.
I guess this one.
Seems like that was a bigger one was going.
The fatter one actually was in the lead there at the end, but not significantly. Pretty much a tie. Technically, I would expect this one just to be slightly faster, but not significantly. So, congratulations to the tie. So width does not seem to have much of a difference there. Now let's just go smaller. Assuming the width indeed is really not significant, we got small one, big one, and a tie. So the big one, small one, tie. And I'm still gonna put neither up there. At some point, I'm just gonna drop that because they haven't burst into flames yet. I'm still assuming that will hold. All right, who says the big one? We'll make it down first. 1, 2, 3, 4. Small one. 2. A tie. Everyone else? Neither? Let's make sure this actually is rounded up the roll. Yeah. All right. 3, 2, 1, go. That one was slightly ahead, but. All right, so that last one especially was a tie. The other one, it looked like one of them was slightly ahead, but not significantly. So, congratulations. A ping pong ball, and those are roughly the same diameter, although diameter did not seem to have an effect there. So we got a ping pong ball, or potentially just a table tennis ball, and the roll. So the ping pong ball, the roll, or tie, and again, let's just assume one of them will finish. All right, so ping pong ball. All right, try that again. Sorry, hands back up again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The roll. Tie. Place your wagers. Oh. Like the ping pong ball on that one. That was a little bit more significant than what we had been seeing. We'll flip it in case there's a table bias. The ping pong ball won. So congratulations to those 10. All right, now, why?
Cause it's a ball,
Pardon?
cause it's a ball.
Suppose I did 2 balls then. Hollow ball and a solid one. Which one would you think is gonna make it down first?
The one that weighs more.
This one? Let's find out. All right, so we have our first speculation there that it has something to do with the weight. It looks like the heavier one was ahead that time. Both sides. Stop. Apparently you can't go up a straight line. See if I can do that one a little bit better. Possibly the table's just leaning. All right, so the heavier one. So let's find out if that's always going to be the case. Not the ping pong ball. Where's the rubber bouncy ball go? All right. So by your reasoning so far, this one would win. pretty much a tie
At the
there.
same time, we have the tie.
We also did demonstration earlier when I had the two cylinders, or annular cylinders, two discs, no, annular cylinders. This one, actually, I'm not quite sure which mass is greater. That one's a little bit thicker. But mass is not the whole story. Anyone else want to speculate?
Maybe. Like the ball is round on all the surface,
Okay.
so if you're rolling all the time, I don't know, does that make any sense, but kind of.
The fact that it
It's a
rolls no
sphere.
matter what?
Yes, it's a sphere.
And the cylinder also rolls as long as it's oriented this way. Do you feel like the cylinder sort of got off track?
No, I feel like it slows it down, cause it's not. I think it's less aerodynamic because of that.
I'm feeling very confident in saying that these are not going fast enough for air resistance to be a factor. Even for the ping pong ball, which is probably the lightest thing that we're gonna roll. Lacey?
Is it how dense they are? Like how dense the ball is? Like the ping pong ball was slower because there was more like, I don't know how to describe it, but there's less density to it. But the other two balls, they were the same because they had the same amount of density inside.
Alright, so if I did. Okay. So if I did these two things, which one would you think would make it down first?
I guess that one because of what I said.
This one?
Yeah.
No, that seems to be holding right there. Ooh. These have different densities. This is aluminum and this is either